Welcome to the lecture 3 on the mathematical physics course. So in this lecture I would be discussing most importantly the problems on the matrix, but before I jump into the problems I am going to give a brief introduction about the things that you already know, right? You can revisit your BSc days or 12th class where you would get details about the basics of matrix, but I am more concerned about the problem solving techniques of the matrix. So that is why after giving a brief introduction I would straightforwardly jump in solving the questions of the matrix, right? So the first one is, what is a matrix? As you already know, matrix are a set of numbers, datas or some informations that are arranged in rows and columns, so they form an array, right? So you can see here I have written in the third bracket or in the parenthesis certain sets of numbers that are arranged in a regular fashion. It has three number of rows, 3 rows and 3 columns, right? So it is a 3 cross 3 matrix. It is a square matrix that you already know. Now the next important thing that it will be coming up in the lecture is the trace. The trace is the most important thing. So trace is like the sum of the diagonal elements, right? If you sum of the diagonal elements of a matrix, it would give you the trace of the matrix, provided the matrix should be a square matrix. Suppose 3 cross 3, 4 cross 4, 5 cross 5, 2 cross 2, right? So I'm sorry, right? So this is it is 2 cross 2, right? So this is the square matrix. Then we have the eigenvalue equation, that is, or the characteristic equation. Suppose A is a matrix and you have to find what are the eigenvalues, then you can use the characteristic equation, that is A minus lambda I. Suppose A is 3 cross 3, then I should also be the 3 cross 3 identity element. And certainly, as the dimension is 3, the number of eigenvalues, that is lambda, would have 3 values. So this is the characteristic equation. So these things are the general prerequisites that you would be knowing, right? And if you forget these things, you can revisit your BSc days to have a brief introduction about the matrix. The most important thing is that how you're gonna solve the problems, because these things are never asked in the CSI NET exam, that what is an eigenvalue, what is trace. You have the application of these properties or the information that you already know. So in my next slides, I am going to slowly move to the problems by discussing some properties of the matrix. So in this slide I am going to discuss two of the most important properties of matrix, right? These two properties are very important for you to solve almost 80 to 85% questions that come from the eigenvalues, right? And eigenvalue problems are very common. Generally you get 5 to 8 marks from eigenvalue problems. So the first property is that the product of eigenvalues of a matrix is equal to the determinant of that matrix, right? So suppose a matrix A has eigenvalues lambda 1, lambda 2 and lambda 3, then the product of the eigenvalues, that is lambda 1 into lambda 2 into lambda 3, will be equal to the determinant of the matrix A, right? So this is the first identity or property you can see. Second one is that the sum of the eigenvalues of a matrix is equal to the trace of the matrix. Suppose A has the eigenvalues lambda 1, lambda 2 and lambda 3, then sum of the eigenvalues, that is lambda 1 plus lambda 2 plus lambda 3, will be equal to the trace of the matrix A. And trace of the matrix A is sum of the diagonal elements, right? Diagonal elements. So these two properties, believe me, are very helpful to solve almost 80 to 85% problems that come from the eigenvalue part. So one such problem is given below, that came in CSI NET June 2011. Consider the matrix M, and it is a square matrix 3 cross 3. Then the eigenvalues of M are. So use the first property, that is trace of M. As you can see, the trace is the sum of the diagonal element. It is 1 plus 1 plus 1. It is 3, right? Similarly, the determinant of M, right? If you calculate this, you would see it is 0, right? So you can see the determinant of M is the product of the eigenvalues. From the options there are certain eigenvalues. I need to see which set of the eigenvalues obeys these two equations or these two properties. And trace of the matrix is equal to 3. This is 3 trace, sum of the eigenvalues is 3, sum of the eigenvalues is 3, sum of the eigenvalues is 3. Determinant of M is 0, that means product of these values is 0, it is okay. Product of the values are 0 is equal to okay. Product of this value is not equal to 0, it is not equal to 0. That means these two options may be correct. Now out of the two options, you have to figure out which option is the correct one, right? Now for this, you cannot solve this characteristic equation because it would take large amount of time. So you can remember one trick, that if all the elements of a square matrix are equal, right? Suppose A, then the eigenvalues are generally trace, 0, 0, because it is a 3 cross 3, right? So there will be 3 eigenvalues, one of it would be trace of the matrix. So you can see on the options, this one is matching, it is the trace and the other two are 0. So this is the correct option. It obeys the 2 also, and this trick is very essential to solve this question because you have to figure out which one is the correct option. You can remember this trick. That is, all the elements of a square matrix are equal, then the eigenvalues are trace and the other two eigenvalues are 0. So this is how we solve this type of questions, right? Some of the important properties of the matrix, right? So the first property is that if you have two matrices, suppose A and B, the determinant of the product of the two matrices is equal to the individual product of the determinant of those matrices, right? So this is quite clear, right? So this is the first property. Second property is very important. See, those properties which are a bit uncommon, these properties are very helpful. See, determinant of e to the power a matrix A is equal to e to the power trace of that matrix, right? You would see in the upcoming slide that a math is based on this property. The third property is that determinant of adjoint of A is equal to determinant of A to the power n minus 1, where n is order of the matrix. By order I mean, suppose A is 3 cross 3 matrix, then n would be 3. Okay. Fourth one is also very important. The determinant of a constant term multiplied with the matrix, it would be constant to the power order of the matrix multiplied by determinant of the matrix, right? Fourth one is A into adjoint of A, right? It would be determinant of A, In. I is identity matrix and it is of the order of the matrix. Suppose A is of order 3 cross 3, then identity would also be 3 cross 3 matrix. Sixth one is pretty simple. It is trace of matrix A plus B. You can use the distributive property, that is trace of A plus trace of B. Seventh one is like the commutative property, that is trace of multiplication of two matrices is equal to the trace of the commutation multiplication of the same two matrices, that is trace of AB is equal to trace of B. Eighth one is also very important property. It is a cyclic property. Suppose we have three matrices, then trace of ABC is equal to trace of BCA is equal to the trace of CAB, right? You can use the cyclicity property. So based on these properties, we can solve the upcoming questions that are based on these properties. So let us see. So this is a problem. It came in CSIR net, and the question is as follows: one of the eigenvalues of the matrix e to the power A is e to the power small a, where the matrix A, that is raised to the power E, is given as a square matrix 3 cross 3. The product of the other two eigenvalues of e to the power A is, right? So you can see the hints in the question. The product of the other two eigenvalues means one eigenvalue is given, the product of the other two. That means the one eigenvalue is e to the power A multiplied by the product of other two is equal to the determinant of the matrix. Determinant of which matrix? This matrix, e to the power A, right? This is the general thing we know. The product of the eigenvalues of that matrix is equal to the determinant of that matrix, right? Product of the eigenvalues of the matrix is equal to the determinant of the matrix. Now see the last property in the previous slide. The determinant of e to the power a is equal to e to the power trace of a, right? So it is e to the power trace of a. Trace of a is a plus 0 plus 0, right? So it is a, right? So e to the power a into product of the other two eigenvalues is equal to the e to the power a. You can cancel this out. So the product of the other two eigenvalues is equal to the 1. So this is the correct option. So see, with using this property you are able to solve this question in seconds. If you solve by any other method, suppose you expand e to the power a, then you use some approximations, you will arrive at the answer, but I can bet it would take a minimum of half an hour to 45 minutes. You can try it out. And also in the exam there will be a lot of pressure, so it will be very difficult for you. So it is better if you remember some of the uncommon formulas that are helpful to solve these types of questions, right? So let us move to the next question. So this is a question, it is also based on a property. It came in CSIR December 2012. That consider a given 2 cross 2 unitary matrix U satisfying the unitarity condition, that is u dagger u is equal to u dagger is equal to 1, with determinant of u is equal to e to the power i5. One can construct a unitary matrix V which obeys the same unitarity property with determinant of V equal to 1. From it, means from U we can construct the V, that is another unitary matrix. How we can construct it, that is asked in the question. So you can see the options are multiplying u by e to the power minus i5 by 2, multiplying u by e to the power minus i5, multiplying one single element of u by e to the power minus i5, multiplying one single element of u by e to the power minus i5 by 2. So you can see that determinant of u is equal to e to the power i5, right? And you have to find determinant of v is equal to 1 from this property, that is from u itself. So how you are going to find it? Suppose I am multiplying both sides. I have to make this side 1, right? So I can multiply by e to the power minus i5, right? So it would be also e to the power minus i5 multiplying from the left hand side. So it is 1, right? And suppose this is a constant term, and you can use the reverse property that k constant multiplied by determinant of a is k to the power n determinant of a, right? Right. So u is a 2 cross 2 unitary matrix, right? So if you solve it backwise, it would be e to the power minus i5 by 2 determinant of u, right? Now you can see that if you solve like this, that e to the power minus i5 by 2 u, if there is a constant, if you take it outside, it would be e to the power minus i5 by 2 to the power 2, because u is 2 cross 2 matrix, right? See, e to the power minus i5 by 2 into u, if this is a constant, it would be e to the power minus i5 by 2 to the power 2, because n is here the order of the matrix A. So here n would be to the power n, this n would be order of the matrix U, that is this 2 is the order of U. U is given as 2 cross 2 unitary matrix, right? That is why it is 2. So if you do it, it would be e to the power minus i5 into u. See, if you are using this one, you are getting back to this one. So I am using the backward method. So you see the right hand side is 1, and this is the form of V I can write, and it is equal to 1. So how I am getting V? I am getting V by multiplying u with minus i5 by 2. So see, this is the correct answer. So see, you can use the simplest properties to solve these types of complex problems. This problem is not simple. Just because of this property, you can figure out, and you have to use some of your intuition and brain also, right? See, you have to make this side 1, and you have to use the reverse property. So this is how you solve the matrix problems. You have to figure these things out. You have to learn these things. CSR demands this thing from you. So let us come to the final question of this video. And I think this much questions are enough for you to have a clear idea about how to solve the eigenvalue equations and the similar equations that come from the properties of the matrix. Now see, this question came in CSIR in June 2017. Which of the following cannot be the eigenvalue of a 3 cross 3 matrix? Real 3 cross 3 matrix. Now as the question suggests, if it is a real matrix, the elements are real, right? That means the trace of the element will also be real. Trace of a real matrix is also real, right? So these are the eigenvalues. Then what would be the trace? The trace would be the sum of these eigenvalues. So as the eigenvalues are given in the options, the correct option would be sum of this eigenvalue is real, because I am dealing with a real matrix. So out of these options, the option that would give the sum of the eigenvalues equal to real, it would be the correct option, right? Because the trace is the sum of the eigenvalues. So see, it is sum of the eigenvalues, it is 0, it is real. Sum of the eigenvalues is 3, it is real, right? Here the sum of the eigenvalues is 1 plus e to the power minus I theta plus I theta. See, it seems that it is not real, but you can solve this like 2 e to the power minus I5 plus e to the power plus I5 divided by 2. It is 1 plus cos theta, right? So see, it is real. So this is also real. But this last one, that is I plus 1 plus 0, the trace, that is the sum of the eigenvalue, is not equal to real. So I am sorry, in the question regard, it is cannot be the eigenvalue, that is D cannot be the eigenvalue, because I am dealing with a real matrix, the trace is not real. So this is why this is the correct option, right? So it is not that you have to know the eigenvalues of a real matrix. You can generally use your idea that the real matrix will contain real elements. That is that the trace should be real. It is simple. If the elements are real, then the trace will also be real. It is quite simple. So using this property, you can solve this question also. So that's it for today. I hope you have enjoyed this video. You can subscribe my channel, and if you like this video, you can share it with your friends, and you can press the bell icon for receiving the upcoming updates. So in my next video, I will be posting a lecture 2 on the matrix, in which I will be solving Cayley-Hamilton theorems and other important properties and other important problems related to those properties. Till then, if you have any problem, you can post it in the comment section below. So thank you. Bye bye.